Okay, let's have a look at day 10. So, what's it saying? Syntax scoring. You ask the submarine to determine the best route out of the deep sea cave, but it only replies, syntax error in navigation subsystem online, all of them. All of them. The damage is worse than you thought. You bring up a copy of the navigation subsystem, which is your puzzle input. The navigation subsystem syntax is made of several lines containing chunks. There are one or more chunks on each line, and chunks contain 0 or more other chunks. Adjacent chunks are not separated by any delimiter. If one chunk stops, the next chunk, if any, can immediately start. Every chunk must open and close with one of 4 legal pairs of matching characters. So we have parenthesis chunks, we have square brackets chunks, we have brace chunks, and we have angle bracket chunks. So a pair of parentheses is a legal chunk that contains no other chunks, as is this. More complex but valid chunks, so we can have this inside, could do something like this, yeah. So we can nest them. Can we like interleave them? Yeah. So like this isn't part of this, but actually part of this. Or even this. Some lines are incomplete, but others are corrupted. Find and discard the corrupted lines first. A corrupted line is where one chunk closes with the wrong character. That is, where the characters it opens and closes with do not form one of the 4 legal pairs listed above. Examples of a corrupted chunk include, yeah. Such a chunk can appear anywhere within a line, and its presence causes the whole line to be considered corrupted. Okay. For example, considering the following, some of the lines aren't corrupted, just incomplete. The remaining 5 lines are corrupted. So it says expected a bracket but found a brace instead. Gosh. Because he got this. So let's have a look at this one, see if we can do this one by hand. Let's create our input day 10.text. Nope, that was the answer to yesterday's. Let's copy. Let me go here. So we can start to like split this apart. So we know that's a chunk. We know that's a chunk. That's a chunk. Yeah. So you can see if we start to break this down. We can sort of do that. Like, what is going on here? So I assume, see that closes that, but I don't think we, so like, I'm pretty sure we can't do, how would you even do that? Like this. Because this chunk contains an incomplete chunk. So as you can see, this, so the last open to be pushed onto the stack is this angle bracket, square bracket. Okay. So yeah, I think for this we're going to need to implement like a stack of some kind. Stop at the first incorrect closing character on each corrupted line. Did you know that syntax checkers actually contest? Let me come back to this. Did you know that syntax checkers actually have contests to see who can get the high score for syntax errors in a file? It's true. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. Okay. In the above example, an illegal parenthesis was found twice, so that's 2 times 3. Yeah. So the total syntax is such a points. Find the illegal character in each corrupted. Find the first illegal character in each corrupted line of the navigation subsystem. What is the total syntax error score for those errors? Okay. So I'm going to take this line and make this our puzzle input. For day 10, let's create our day10.c. Let's go to our main and make sure we include day10.c and run it. Compile and run. So day 10 took 0 milliseconds because it's currently not doing anything. So I think we're also going to create our stack .h. So I'm going to create a structure called a stack. It's going to have and we're going to make a stretchy stack so it can reallocate. We don't have to worry about the count. So it's going to have 2 variables called our count and capacity. And it's going to be a stack of integers, maybe like an i32 stack. Or it could just be a stack of sort of our element size. Let me go back to our day 10 and let me just include stack.h. See if that compiles. Yeah. And then it's going to have a void star to the data. So that way it's something we can reuse in other projects. So then what we're going to do is make stack, and we're going to have our U64 capacity and our size t elem size. So our struct stack, say that's st, our st.count is going to start off with our capacity. It's going to equal to our capacity. Our st.elem size is going to equal to our elem size, and then our st.data is going to equal to malloc capacity times elem size. And we're going to return the stack. Does that compile? So if we want to push something on the stack, and it's going to return the stack. In fact, I'm going to call this stack alloc. There you go. So we're going to have our stack free, and that's going to take in our struct stack, and it's just going to do free st.data. And it's not going to return anything, it's going to be void. And then we're going to have stack push, so our struct stack st, and then guess what do we push? And so we wanted to push I32. Yeah, doing void data. For example, if I did just a stack test, what I kind of want to be able to do is, sorry, let me just do that for now. If I create my struct stack values and call that stack alloc, give it 10 like size of I32. So it's going to create that, and then I sort of want to say stack push onto values, the value 12. But I might also want struct stack characters equals stack alloc 10 size of char, right? And I want to be able to do stack push characters, the letter A. In which case I would just have to create one of these for each type I want to push on. So it would be like st data st.count equals value. But I would have to check if st count is equal to our capacity, we would have to realloc. So st data equals realloc. Let's remind myself what c realloc is. Realloc, you pass in a pointer to the data and then the new size. So what I would do is I'd say st capacity times equals 2. I'll double it, pass in st data, and it'll be st capacity times st.lm size. And that's push. And then like I32 stack pop I32 struct stack st. I'd say if st.count is greater than 0, I would get the value, so I32 value equals st data printf error stack pop error pop from stack with 0 count. There we go. Cool. So let me just test this. So printf stack %d, and that's going to be stack push I32. I want to see stack pop I32, and I'm going to give it values. So you always give it a pointer to it. And then stack. So I could like copy these if I wanted char. Then this would basically become char. Same here. That's the only difference. Push char, pop char. And then that would be %c. And then to run this, I'm just going to go to day 10 and do stack test, right? And then we'll do stack free at values and stack free at characters. Now if I compile this, cannot convert. Yeah, that needs to be a pointer to characters. If I run it, 12 and A. Now is there any way I can sort of, because the key difference here is just this and this. So I guess the question is C void function argument because I know we can do a void pointer. Like pass any type. Will I have to do it as? So I could do a switch. could do that. In which case I would pull not great. I'd have to do it as a macro. That's the one thing about C I do miss. Well, I'm not a fan of templates in C++. But there would probably be a nicer way to do this in C++. Because essentially what it would be is define stack push and then I would get you. Or rather, yeah, it would be this, wouldn't it? And then this would just be type data, type, and then this becomes push I32. Does that still work? I do know of a library that already exists, and it's called STB. Nothing's STB, and they have a stretchy buffer, I think. So I'm just gonna I'm not gonna use it, I'm just gonna look at how they do the Typesafe dynamic array and hash table for C. So, and the way that works is you declare empty dynamic array of type T, access the ith. So I don't know how much of how many macros they use. Let's have a look. They do something of length capacity. That's the hash table. I don't want the hash stuff, I just want AR put maybe grow equals V. Where's the structure, length, capacity, array header? What's this? Header. Array header pointer T-1. Is that even possible? A So ignoring the growth bit, can I just do stack data stack count ++ equals V. And we're just going to set you to V. Does that compile? 83. Stack push values. Oops. Void illegal with all types. Void star. And the reason is because when we do AR put length equals V, let's have a look again what it says about declare an empty dynamic array of type T . Interesting, they do this slightly differently. So this arm maybe grow. What's this array grow? Where's that set? That's if C++. This array header is interesting. Where did they put it? Did they put it before? They do it in a really interesting way. So yeah, I would have to sort of do type I32 differs in levels of indirection from int. Yeah, this is. I'm not a fan of it too because it's just really complicated. Right. Even if I was to do it in sort of this form where I say type and then I could do like type data equals type and then data. I'm just going to say data 0 equals value and get rid of this line. Does that compile? That compiles. There we go. I'm not even sure we need to do that. I can just do V and get rid of this one. And then this maybe grow can be bool stack maybe grow struct stack st. And then I just cut you out, auto stack, maybe grow. Return true, return false. And this just becomes stack, maybe grow, st. Right. And then I'll define another one called stack pop. again with the type. And that's just going to do if st count is greater than 0, it's going to be type data equals type st data type results equals data st count -1 st count minus return results. Otherwise we'll return 0. So then this just becomes stat pop I32. Let's have a look here. Here. What's wrong with that now? Again, a syntax error. Probably because I've put that in there, so I32 val equals stat pop. That values I32. Because I've got like return, haven't I, inside a. Because this gets. That makes sense. I'm not a fan of that. Let's see how, again, they do it in array pop. Instead of just do a much nicer way. I'll just call that pop2. They just do like st count minus. this, which really just becomes define stack data st type. So that just becomes equals this, right? Does that work? That works. So, yeah, this is the world of. So this just becomes stack data st type. So that can go. So that means we can get rid of all this. Stack popchar. So we do stack push, stack pop. I wonder if we can even just put you into here. So this just becomes stack push, stack pop, I run it, and there we go, we got sort of a generic stack. Cool. So let's go back to day 10, let's get rid of our test. Alright, probably going to want to do our own file reading fopen, or not. We could just do, yeah, okay. Read puzzle input day 10.text. We're going to want our use 64 input count. For now, I don't know what that's going to be, and then day 10 read input. And that gives us our file. It gives us our count and our user data. Right, so we're going to do the usual scan f, give it the file. We're just going to scan one character at a time at C. Right, so we're going to have our char C. It will return a scan count, and if our scan count is greater than 0, we'll do our logic. And return true, otherwise return false. Or I could just do scan count, that does not equal 0 down here. Okay. So for now, I'm going to create our stack here. So we're going to have our structs. Let me just go to our stack.h. Stack. So this is going to be our, what did they call it in this? Chunk, our chunk stack. going to equal stack alloc and we're going to start off with, I don't know, give it a size, capacity of 50, and it's going to be size of char. So we're then going to do a switch on C, and we're going to have case. So we're going to have all these different cases. So if it's a parentheses, or if it's a brace, or if it's a angled bracket, we're going to do stack push chunk stack char C. That's how that works. Otherwise, if it's a close, so in these cases, so let's have a look at this. So to begin with, we're going to push this onto the stack, and then 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 we're going to come across a close brace. And so we're going to look at our stack. So we're going to get our char. I'm going to call this our last bracket equals stack pop chunk stack. We might want a peak, but if our last bracket and then we want to sort of see if our last bracket was this, we want to see if it is this, and the way we can do that is sort of do these in pairs. So struct bracket pair char open and char close. And I'm going to do struct bracket pair bracket pairs for equal to, I'm going to say that, and this. So we do this for each of the 4 pairs. So 1 1. And then we can sort of just have a function that says they do bracket pair match and job close. Sorry, 1 second. Okay. Do bracket pair, or does bracket pair match, and then I can just sort of go through do this. True. Otherwise return false. And do that. So then I can say if does bracket pair match last bracket, or I can call this the open bracket and the current thing. If it does, printf day 10 found matching brackets. So that's our open bracket and C. Else I can say printf day 10 corrupted chunk starts with %C and ends with %C. And again, open bracket and C. So let's compile U. U64 differs, and so you need to be that. Run it. Found corrupted chunk that starts with and ends with. So our stack pop, let's just do this. Print f push %C new line C. And let me get rid of U. That might help. Let's call this. So we're pushing that. Yeah. Found corrupted chunk that starts with \8e and ends with. So it looks like our open bracket isn't working as I had hoped. Popping /8e. So let me go to my stack again. Stack alloc size of char at characters char. And if I come to open day 10, press play, let's step over, let me get rid of all these, and I just want to see our chunk stack. So count 1, and there's our data. So if I look at chunk stack.data, and if I make you a char star, you can see it is doing that. Press play, skip over, stack push. Oh, interesting, that's now equal to that. And what's 1? And what's 2? Our count is equal to 1. Ah, because we're reconstructing. Okay. So we actually want to cut you out, put you here, and then pass in our chunk stack. So then our struct stack chunk stack is going to equal our user data. It's going to be so these no longer need to be addresses of here we go, day 10 found matching brackets, day 10 found matching brackets, day 10 found matching brackets, day 10 found corrupted chunk that starts with a square bracket and ends with. So we can see here expected that but found this instead, which is what I think is happening. So then what you want to do is, if it doesn't match, go to the next line. Which would basically be f scan f new line, right? Or rather, I want to seek to a new line. So that's basically void seek to new line file f. It's probably a better way to do it than just fscan. It's fseek. or the f get c. So while it does not equal new line, I'm going to say c equals f get c file, and f end of file f. So that's going to seek to new line. So I run that. So as soon as we found a corrupted chunk, it's going to stop. Cool. So we actually want a new structure called our day 10 or sort of read context, and that's going to have our bracket, our day 10 read context. That's going to have our, not bracket pair, sorry, it's going to have our struct stack chunks. I'm just going to call them chunks. We're going to have a line number. So it's actually going to be a pointer to a line number, a pointer to the stack. Line number. So this becomes our day 10 read context. I'll just do ctx. So then this becomes our ctx chunks, ctx chunks. So I want case new line. Our ctx dot line number gets incremented. Same here, our ctx line number gets incremented. And then our struct day 10 read context context ctx dot chunks is going to equal our chunks, and our ctx line number is going to start with a. So let's compile that. Syntax error 55. Case new line. Found corrupted chunk on line. There we go. Sorry, that's line 64U. So, how much your bracket? Found corrupted chunk on line 0. I'm just going to add 1 to that so it matches our input. So, if I now go back to my example code, and we're going to paste it with this and run it. In fact, let me compile it, run it. Let's get that +1 in there. Found corrupted chunk on line 3. found corrupted chunk on line 5 on line 6. So there's line 3, 4, 5, line 6. So it looks like it's doing it right. Corrupted chunk on line 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And there should also be one on line 9. Okay. This is actually going to become static. Can I do like a list, like something like that? Does that work? Cool, I can. So we'll do it this way. Oops. So these can go here. There should be 4 of them. And so 3 points. Square brackets is 57. Brace is 1197. And his angle bracket is 25137. So that works so far. Does bracket match pair? And then what we'll do is I32 get points for bracket. I'm going to define day 10 num bracket types to be 4 here, so we don't have that magic 4 number. Then we basically say if bracket pairs I dot close is equal to our bracket. I'm going to say our close bracket. We return bracket pairs I dot, what did I say, points. Otherwise we'll return 0. So then in our day 10 read context, we'll then have our sort of our score here. Make sure we 0 that out. So our context.score is equal to 0. And then basically we will say our ctx.score plus equals get points for brackets, and we'll pass in the character. And then here we'll do if we did read our input. I'm going to printf day 10 score is percentage nice 64u, and we'll pass in our context.score. So let's run that. So fan matching brackets, blah 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 blah. Come on, let's go down to the end, and our score is 26397. 26397. So we can now print. Here's what we can do: tidy you up, not, get rid of you, get rid of you. So here we go. I'm just gonna do this, simplify that. Cool. So far, day 10 is very quick to compute. So let's try it with the actual puzzle input. Copy you, paste you. Let's run it. So it's finding a bunch of corrupted lines, and it's giving us our score, which is this. So let's run that and see if this is the correct answer. That is the correct answer. Okay, so part 1 was fairly simple so far. Let's go into part 2. Now, discard the corrupted lines. The remaining lines are incomplete. Incomplete lines don't have any incorrect characters. Instead, they're missing some closing characters at the end of the line. To repair the navigation subsystem, you just need to figure out the sequence of closing characters that complete all open chunks in the line. You can only use closing characters, and you must add them in the correct order so that only legal pairs are formed and all chunks end up closed. Okay, that should be fairly simple. Did you know that autocomplete tools also have contests? It's true. The score is determined by considering the completion string character by character. Start with a total score of 0, then for each character, multiply the total score by 5, and then increase the total score by the point value given for the character. Okay. 1, 2, 3, 4. So the last completion string okay, well, let me just put these values in here. So these become sort of the error points, and I32 complete points. So that becomes 1, 2, 3, 4. Let's just make these a little nicer. There we go. So where we do score, get points, get points for bracket. This becomes get error points for bracket. And then we're gonna copy paste you. Get complete points for bracket. Okay. So to complete it, basically what we need to do is well, if we ever see a new line, we know we've reached the end of a line and it's incomplete. So what we would then need to do is start to unwind the stack. So it would be a bit like a void day 10 complete line. And we're going to pass in our context. So yeah, day 10 complete line, pass in the context. And so that's as simple as like this, really. To be honest, this can now just be get bracket pair. Get bracket pair from closing bracket, and then this just returns, you just return the bracket pair, right? Otherwise return null, which means we can get rid of these two. This becomes struct bracket pair equals get bracket pair from closing bracket, and then context score plus equals pair dot error points. Let's copy this. So we also want to pass in So basically what we're going to do is while our context.chunks.count is greater than 0, we're going to say our char open bracket is equal to stack pop context chunks char. Then we actually want to get the bracket pair from our open bracket. So let's copy you, paste you. So that's open bracket. There we go. And then the autocomplete character basically becomes the pair.close. So we have sort of our error score here and our U64 close score, or sort of complete score here. So yeah, this becomes our error score. So the error score is context.error score. The context.complete score should equal 0 as well. Sorry, let me get you, duplicate you. So our oops, our complete score, and it was start with a total score of 0, then for each character multiply the total score by 5, and then increase the total score by point value. Autocomplete tools are an odd bunch. The winner is found by sorting all of the scores and then taking the middle score. There will always be an odd number of scores to consider. In this example, the middle score is so it's per line. Ooh, I don't like that. Okay. So again, we can sort of do struct stack our complete score lines equals stack alloc. Again, I don't know. And we're going to have a size of maybe U32 should do it. So actually we're not going to have a complete score. But we are going to have a struct stack complete score lines. And then in our complete line, we'll have a complete score here, which starts off at 0. And then our complete score is going to equal to our complete score times 5 plus our pair dot complete points. And then we're going to do stack push context dot complete score lines. U32 complete score. How is that? This now returns a bracket pair. I guess I have to return a bracket pair. I'm just going to create a null bracket pair here. So we return the null bracket pair. Chunks. And then our open bracket. Okay, so if we run this, it's doing that. So I can sort of do printf day 10 completed line I64U. Scoring I'll just do %u there, and then it's going to be our context.line number and our complete score. So if I run it, let's have a look at the output. So it's saying found corrupted chunk, completed line 0, scoring a lot, complete points. Let me just run that again. Completed line 0, scoring that. Line 6, scoring that. Okay. So then we need to get the middle value. So again, we just do the Q sort. We pass in our context dot complete score lines. So yeah, what we want is, we know our complete score lines is U32, so we actually want, U32. I'm just going to say score lines equals U32 and context dot complete score lines dot data. So it's score lines, it's context dot complete score lines dot count, size of U32. And then it's going to be Q sort ascending. So I think that's right. And that needs to be a dot. And then it's just going to be the middle number, so our U32 middle complete score is just going to be our score lines. I'm just going to cut U and just call that score line count. Score line count divided by 2. And we're going to printf day 10 complete score, or rather middle complete score, is %u. Let's run U. So it thinks this is the middle complete score. Let's run the example code first. So here's our example code. Let us go to the top, delete U, paste U, and let us run it. So complete line 0, scoring 288957. Let's have a look. 5 lines completion screen, so it's done 288957, which is correct. completed line 1, scoring 5566. Yeah. Scoring line 3. Okay, line 3 is wrong, as is line 6. So what I'm going to do is printf day 10 that's going to be a context line number, and then I'm going to printf just the closing character, which is going to be our pair.close, right? And then that's going to be a new line there. So let's have a look. So this needs to be +1. Same here. Right. So if we look at this, let me go to our scratch. Let me get you, delete you, and let's have a look. Let's copy that and paste. So if we look at, it's tried to complete line 1, which is the correct completion. It's tried to complete line 2, which is the correct completion. It's tried to complete line 4, which is the incorrect completion. And I think I know why. Actually, I don't know why. Because when we corrupt a line, that's why. When we corrupt a line, we need to completely clear what's in our stack. And so that's what I'm going to do here, is if I go to my stack.h, what we want to do is basically say void stack clear. We take in our struct stack, and all that does is it just sets st.count back to 0. So if we get a corrupt line, we're just going to say our stack clear, and we pass in context.chunks. And now if we run this again, we should see, and I go back to our scratch, for line 4, yeah, and then line 7. Oh, need to sneeze. 1 sec. Alright, better. Yeah, and finally our... Now the last line we don't get, because the last line doesn't have a new line character, it has the end of file. So what we can do is could we just do case 0? Does that work? what we could do is we could say if f end of file, then we're just going to force C to equal a new line. And that way, it should also do the last one, which it's not doing. Probably better to do it like this. That needs to then go below the switch. No. Where did I just put it? X. And that needs to go below the switch. We're still not seeing that last line in day 10. 9, line 10. That's because f end of file f is returning false. Let me just do context.line number +1 and run it. 1, 1. We never get to line . Let's seek the new line. Do. 1, 2. Four, 5, 6, 7, 8, 9. So we just never get to . We should get to the end of 9. I guess we could also say if scan count or scan count is equal to 0. There we go. Now we're seeing line 10. that. And that is the same as the scratch line there. So our middle score is 1473371. In this example, the middle score is 288957 because there are same number of scores smaller and larger than it. So let me get rid of you, get rid of you. Do this. So we can see completed line 1, scoring that. Completed line 2, scoring that. Completed line 4. Middle score is 1473371, which isn't even one of the entries. So there must be something wrong with our score lines. Let's have a look. So complete score, we're using U32 for a complete score. Size of U32, complete score lines. Complete score lines count. Am I using QSort wrong? Let's go to day 9 because I used QSort in day 9. It's the array, the number of items in the array, the size of the elements of the array, and then QSort ascending. Which is what I do here. The array, the number of elements of the array, the size of the elements of the array, and QSort ascending. And then I get the middle complete score. Should be where's this 147 coming from? Let me just do for I just want to print percentage I32 U new line, and it should be score lines I just want to print all the different scores. What's wrong with that? I'm getting the data. There we go. Context that complete score lines. There we go. Middle score is 288957. I was reading an array that hadn't even been populated yet. So we don't even need that. We can just do that because we already have access to that. I can delete you. Just run it one more time. That's no longer a pointer. Complete score, there we go. So I'm just going to create another one called define day 10 print per line false, just to hide all these prints here. So if day 10 print per line, so there we go, day 10, error score, middle score, took 0.1 milliseconds. So let's go back to our day 10 input, delete U, let's go back here, copy U, paste U, and run it. And on the bigger one, it only took 0.6 milliseconds, and it says our middle score is this large number here. So copy U, go back to U, and submit it. That is not the right answer. Your answer is too low. Okay, so let's print per line. Run it. Our scores are getting pretty high. What is that? We're in the billions. And we're using 32-bit integers. And what did it say? Our score was too low. In which case, let's bump up our complete score to a 64-bit number. So complete score size of U64. So this becomes an array of U64. Let's see if that changes anything. Complete middle score needs to be U64 as well. 89. Where's 89? I64U. So let's see if that makes any difference. Yeah, the middle score is a much higher value now. So let's give this a go. That's not the right answer. Your answer is too high. No, our answer's too high. What we're doing wrong here, because it worked on our input. Let me just create example day10.text. Let me go back to the example. And let's read our example data, run U. So you can see it gives the correct error score and the correct middle score, right? The error score puzzle answer was 415953. Oh, the error score is now wrong, but the middle score 288957. So why has the error score gone wrong? Oh, because the error scar was looking at what the actual answer is for the real puzzle input, but for the example input it's correct. 26397, so that's still correct. Interesting. So found corrupted chunk on line 9, completed line 10. Completed line 1, completed line 2. And if I go to input A10 and I do input A10, you know, there's 90 lines. Just to be certain, let me close you, get our puzzle input, copy and paste, compile and run. So it gives us this big number. And the error score 415953, which is the same one, yeah. So start with total score, multiply the total score to get 0 and then add the value. The middle score. Find the completion string for each incomplete. Score the completion string, sort the scores. What's the middle score? And it was saying this was too high. And before then, oh, it doesn't say what we got. I just want to make sure also we're clearing the stack between lines. But that probably still gives the same value. Let me just make a note of this here. Right, that's what we put in before. So let's print all our sorted numbers. So this is obviously not sorted. And possibly because it doesn't like sorting. Why is it not sorted? Because if we go to common, our QSort ascending, yeah, this should really be like I16, I think, or 32. I'm going to do a U64 version. U64, compile U, probably going to see if we go to 7, qsort ascending I32, compile day 9, that needs to be U64, compile, okay. So if I now run U, is this in ascending order? Still not in ascending order. Sorry. So there should be I32. Go to day 10, U64, compile. Yeah, still not in a ascending order, size of U64. Because it's you can't subtract, right? So you sort of have to do something like this. Return 0 if it's the same. So there we go. Now it's in ascending order. And here's the middle score. We did it! Day 10 done! Whee! Okay. Let me just go back into here, see if there's anything we need to clean up. We can clean up this. Cool, middle score. It's done. I can come back to here, set U to false. Printing each of the lines. We had this, our bracket pair, our read context, our complete line. Can't really see anything that needs to be cleaned up there. We could probably there's no point doing it. I was going to say we could define that U64 for when we're doing like stack push and pop, but I think it's fine. Complete score lines, U64, complete score. That's fine as well. There's 90 lines. There's not going to be more than that, so could probably do something like 50 there as well. Cool. And let me compile that. Just run it one last time. And there we go. It's doing our error score and our middle complete score, and it takes 0.6 milliseconds. Cool. Thank you for watching. Join me soon for day 11.